and welcome to IAS Masterclass. This is Mr. Jose. In the climatology series, in the third part, let us discuss jet streams and Rossby waves. Why is climatology so important for UPSC? For a couple of reasons. It's the most dynamic subject in physical geography. Why is it dynamic? It is always relevant. Courtesy, climate change. So as a result, 3 to 5 questions are asked in mains GS1 and 2 to 4 questions in prelims, the climate change part particularly. This subject, the approach to learning this subject is a little different from other parts of geography. Why? Because there are no big jargons or words here. There is more logic and fundamentals. Once you're getting the fundamentals and foundation done, the subject is a very breeze to study. Of course, it's valuable for future bureaucrats. The syllabus for general studies from climatology part includes atmosphere, temperature and pressure changes in troposphere, temperature inversion, pressure belts, planetary winds and local winds, jet streams, humidity, precipitation, clouds, types of rainfall, cyclones, both tropical, extratropical, and temperate cyclones, climate classification, and climate change. Okay, let us start off with our video. In the previous video, we were discussing about surface winds, planetary winds, and local winds. Those were all surface winds, but that is not all. There is something called an upper atmospheric circulation which also happens along with it. And what happens is when there is rising air, where you have, say for example, in the equatorial low pressure belt, when the air rises like here, what happens? The air rises over here, it progressively cools down, and then it is drawn towards the poles. Now what happens? Majority of this air comes down, sinks around 30° north and south, where we have the subtropical high pressure belts. Now, coupled with the surface winds, we have something called a cell which gets formed. This is a result of something known as geostrophic wind. That is, we were discussing about planetary winds which were actually surface winds. Now what happens around 2 kilometers in altitude? What happens to the winds there? Here the wind system would be devoid of any friction. So ground friction cannot affect in any way. The wind system cannot be affected by the ground friction. Now this sort of winds are known as geostrophic wind. These geostrophic winds actually cause a kind of a cyclical cell to be formed. Now in between the subtropical high pressure belts and the equatorial low pressure belt, we have something known as the Hadley cell. Between the subtropical high pressure belt and the subpolar low pressure belt, we have the Ferrel cell, and between the polar high pressure belt and the subpolar low pressure belt, we have the polar cell. So these are 3 circulation, upper air atmospheric circulation, which we need to understand. Now this is the basis of jet streams. Now we have all heard of jet streams. What are jet streams? See, the story goes like this. During the Second World War, when America was trying to invade Japan, fighter planes from the western coast of, that is the Pacific coast of America, started their onwards journey towards Japan. Their idea was to attack Japan. Now what happened was, in the mid-air, they suddenly realized that they were not able to move forward. So it is almost like, it's like a comical situation, right? All these fighter planes were kind of stranded. Why? The reason was there was a wind which was blowing in their opposite direction, and it was blowing at around the same velocity as they were moving. That is when people started realizing, okay, there is something upwards in the upper atmosphere. Now that is not the first time that world has known about jet streams. It was actually a Japanese meteorologist who actually thought about jet streams and all that. This was the first evidence of jet stream during World War I. That is when studies started to be commissioned, and then we now have a lot of idea about what these streams are. These are what? These are streams, as this diagram shows. See, all these streams which are moving in the upper atmosphere predominantly in the west to east direction. Now these can reach speeds up to like 450 km per hour, and that is a huge speed, isn't it? Now predominantly they move in the upper atmosphere. Of course, they move in the west to east direction. There are some, why do we say predominantly? There are some exceptions. In this, okay. Now, where do we find jet streams? Jet streams are found wherever you have a convergence of air masses. Okay, so let's be clear. Wherever you have a convergence of contrasting air masses. Now, where is the contrasting element here? It is the changes in temperature. Now, there is a cold air mass and a warmer air mass. The cold air mass, typically, let's look at the polar region, or let's look at that 60° north. What happens here? There are two air masses which are converging around this latitude. One coming from the polar region, which is very cold. And of course, from the subtropical region, there is an air mass which is moving northwards. Now, these two air masses kind of meet around 60-65° north latitude. Now, what happens? We know this cold air mass actually enters the zone of the warmer air mass, lifting it up. What happens to the temperatures and the pressure? The cold air mass region, the zone of cold air mass, will have a temperature much lower than that of the warmer air mass. What about the pressure? The pressure would be very high. So the high pressure region would be in the region of cold air mass, and the low pressure region would be in the region of warmer air mass. Yes, as we have seen, that when two air masses converge, contrasting air masses converge, the boundary is created, which we call it as a front. Let us take the case of the polar front. In the polar front, which occurs around 60-65° north latitude, what happens? There will be two air masses converging, two air masses of contrasting characteristics. One air mass coming into the equator, I mean towards the equator from the poles, southwards from the poles, and another air mass which is obviously a warmer air mass which is moving northwards from the subtropical region. These two air masses converge around 65° north latitude. Now two zones get developed at that front region. One zone where the region where the temperature is higher, and a zone where the temperature is lower. Similarly, if you look at the pressure part, the region of lower pressure will have higher temperature and vice versa. The air obviously rises in both the columns or both the zones. If you look at the cold air part, the cold air mass part, obviously the air won't rise too much. Why? Because it is denser. And if you look at the maximum altitude by which that air rises, let us say that, okay, it is around 12 km or so in altitude. If you compare the pressures in both these regions, say here at this altitude and a similar altitude in the warmer zone region, you'll find that the pressures vary drastically. In fact, the pressure here, pressure in this higher altitude, 12 km, would be balanced by the pressure around here, because the pressure always decreases with altitude. But in case of the warmer air, the pressure, the rate of decrease with altitude would be much lower as compared to the case of colder air at the surface. That means what? At the altitude of the jet, that means around 12 km or so, you find that there is a pressure gradient which is created. That means a low pressure region is created, comparative low pressure region is created, where in the zone where on the surface there is a cold air mass, and a higher pressure region is created where in the surface you have the warmer air mass. A huge big pressure gradient is created that creates a force through which air will start moving. Now air will start to move from south to north in the upper atmosphere. If you look at the 65° north, and if you look at the altitude of the jet, that is around 12 km or so, you find that there will be an air movement from south to north. Now let us consider Coriolis effect. Anything which is moving in the northern hemisphere will be deflected to its right. That means it will be south to north will be deflected to the right. That is how jet streams are formed. At the altitude of the jet, there is a pressure gradient being created by two air columns above the regions of warmer and colder air masses at the surface at their converging point, that is the front. In this case, you have the polar front and a jet stream is created. That is why we see that these are very high velocity winds. The reason being the huge pressure gradient that is created at that altitude. Now, if you ask me what is the altitude of the jet, is it the same at all the altitude? No. Because we know the troposphere itself changes, right? The height of the troposphere itself changes with altitude. It will be maximum at the equator and minimum at the poles. That means wherever you have a contrast, you have two contrasting regions here. If you remember when we discussed Ferrel cell and Hadley cell, wherever there is a convergence of these cells, that is, wherever there is a meeting point between these cells, you'll find that jet streams are formed. The reason being there is ascending or descending air in huge quantities in those regions. That is why there will be a huge pressure difference when you compare the either sides of that region. That is how jet streams are formed. There are prominently two jet streams. One, as we already discussed, the polar front jet stream, and which is actually at the convergence point between the Ferrel cell and the polar cell. And the second one is the subtropical jet stream. Subtropical jet stream is between the Hadley cell and the Ferrel cell. Both these jet streams are circumpolar. The polar jet is actually the most extensive of jet streams. That is the most thicker and it is extensive. It circles across the globe and all that. Its velocity is much higher. And subtropical jet stream. Subtropical jet stream is more stronger between the Mediterranean region and the Himalayas. It also moves in the west to east direction. It is between the Mediterranean region and precisely if you ask me, it is the Tibetan Plateau. Okay, in this diagram clearly says where you find the jet streams. The polar front jet stream actually is here. That is at the converging point between what? Two cells, right? One is the Ferrel cell and the polar cell, and you have the subtropical jet stream which is at an even higher altitude. The reason being the tropopause is also higher. That means what? The convection currents are also stronger as we go towards the equator. You have a much bigger Hadley cell and a little lower Ferrel cell. There you have at the convergence you have the second jet stream, which is subtropical jet stream. The tropical jet stream, as we have already discussed, the subtropical jet stream is an interesting one. Why? Because it actually changes its direction. Of course, all jet streams change its direction a little seasonally, and also when it passes from ocean to continent and continent to oceans. In the case of subtropical jet stream, we already seen that this jet stream is more stronger between the Mediterranean Sea and the Tibetan Plateau. In the winter season in the northern hemisphere, in this region, the jet streams actually lower its altitude. The altitude of the jet stream gets lowered. That means, and it comes around 7 kilometers or so. That means it gets blocked by the Himalayas, or rather it gets deflected by the Himalayas into two parts. The southern branch actually moves over the northern plain during winter, and the northern branch moves over above the north of the Himalayas across the Tibetan Plateau. Now this is the situation in winter. What happens in summer? At the onset of summer, when the low pressure region extends from the equatorial region into the subtropical region, what happens is this southern branch of jet stream, the southern branch of the subtropical jet stream starts to move northwards like this. It increases in its altitude. It could go above the Himalayas and it slowly merges with the original branch, the main branch of the subtropical jet stream. This northward movement of the southern branch of subtropical jet stream during the early onset of summer is the first indicator of the timely onset of southwest monsoon. I think I'm clear. Okay, this northward movement of the southern branch of subtropical jet stream during the early onset of summer is the first indicator of the timing or the onset of southwest monsoon. Jet streams have seasonal changes. Why is it that they change seasonally? The reason is simple. The contrast between air masses is very important. Of course, you can understand the contrast between air masses would be much higher during winter as compared to summer. Let us take two examples. In the summer, if in the case of polar front jet stream, you have the cold air mass which is coming in from the cold polar region. Now, the temperatures would be somewhere in the range of -5 degrees or so of that air mass during the peak of summer. And what happens to the temperature of the warmer air mass which moves northwards from the subtropical region? The temperatures would be around 10 degrees or 15 degrees. The contrast here is somewhere around 20 degrees at a maximum. But in the case of winter, the colder air mass will have a temperature of like -45 degrees or so, and the warmer air mass will have a temperature of again 5 degrees or even less. That means the contrast is more like 40-50 degrees. This is very high, isn't it? This high contrast actually causes stronger jet streams. In this diagram, if you look at that winter jet stream, it is actually going nearer to the equator in terms of latitude as compared to the summer position of the jet stream. This winter position, look at the speeds, 125 km/h, it's kind of an average speed. It goes even higher to 450 km/h. Now, if you ask me, will this speed be uniform across the world, across this jet stream? Not really. Wherever you have oceanic regions, wherever the jet stream moves over oceanic regions, for the same reason, we'll have, because there will be less contrast over oceanic regions, right? That means jet streams, the speed would be reduced, the velocity of jet streams would be reduced, and coming to the continental regions where there is higher contrast, there will be, the speed of jet streams would be much higher. So this diagram clearly shows the average winter position, which is actually towards the equator in tilt, and the average summer position. The speeds in summer are much lower as compared to winter. So winters are where jet streams, especially the polar jet streams, are stronger. Yes, regarding the effects of polar front jet stream, let's look at the case of Russia as a country. Russia, as we know, is bound by the Arctic Ocean, the north, the left. You have the European mountains, the Alps and all that, and at the south you have the Himalayas. Moisture laden winds to Russia can never reach Russia, in the sense those moisture laden winds will be trapped in mountain ranges, because Russia, the interior of Russia mostly is in that westerly belt which comes from the southwest. So either it will have to come in from the Indian Ocean, or it can come from the Atlantic Ocean. Either way, those moisture laden winds will not be able to impart any moisture to Russia. The reason being, the Alps and Himalayas and Kunlun and Tian Shan and all sorts of Pamirs and all sorts of mountain ranges over there, they block these moisture laden winds and the moisture never reaches there. Coming from the north, since there is the Arctic Ocean, winds cannot take in moisture from cold water. So if the ocean is cold and all that, so the winds coming in from the north into Russia will not be moisture laden. So that means Russia has a problem, right? The only way Russia receives rainfall, if you look at Russia's case, it receives predominantly, the interior part of Russia receives rainfall predominantly during winter. And the major contributing factor is the polar front jet stream. The polar front jet stream, how does it cause rainfall? Now, air enters a jet from its southern side, because the polar front jet stream is from west to east, moves from west to east. It is from the southern side that the air enters the jet. There is an area of convergence which is created very near to the jet, through which air enters the jet. Now, this area of convergence actually causes convergence of air from all quarters, even from the surface. So surface air also gets lifted up into this area of convergence, before it is entering into the jet. That means a slight vacuum is created at the surface, or a low pressure is created at the surface, which crosses this rising air, which is rising to the area of convergence near to the jet, will actually condense and cause rainfall. That means the southern part of the polar front jet stream receives rainfall, especially if it is the interior of continents. Now coming to the northern part of this jet stream, what happens? Air goes out from the jet on its northern side. So that means it enters an area of, there is an area of divergence, and from there it is diverted. Now when this air enters that region is a cold zone. Suddenly this air actually becomes denser and it starts to sink. This increases the pressure at the surface, and so already the pressure is high over there, so it increases, accentuates that high pressure region. So that means it increases the coldness of that place. So that means right side of a, you can simply put in layman's terms, right side of a polar front jet stream receives rainfall, and left side it is relatively colder. Now coming to our subtropical jet stream, we already seen that the subtropical jet stream gets divided into two during winter. That means one branch goes over the northern plains. Now what happens? We already know that the northwestern part of India receives rainfall during winter. We say it is because of western disturbances. Now what are these disturbances? They are primarily the subtropical jet stream. That means whenever you find that there is rainfall in Punjab or Haryana or Delhi or western UP, that means that is the time when the winter temperature would fall in places like Shimla, Himachal, Uttarakhand and all that. So that means what? So northern part of that subtropical jet stream, southern branch of the subtropical jet stream will be colder, and that will be accentuated by the rainfall on the southern part. That means that translates into the northwestern part of India. So if a question arises as to why northwestern part of India receives rainfall during winter, the answer can be explained easily through a subtropical jet stream. Subtropical jet stream and Indian monsoon we already seen, because the northern movement of the southern branch of subtropical jet stream during the onset of summer is actually a best indicator, or the first indicator of the timely onset of monsoon. So these are the effects of jet streams that we can see in across the world. Jet streams have effects on climate, obviously, right? So El Nino, these days of El Nino, which is getting very frequent and all that, jet streams have actually been contributed, so it has been affected also. So it is like jet streams have contributed to El Nino and has get affected by it. Both El Nino as well as La Nina, because these days El Nino's years have extended and the frequency of El Ninos have increased due to global warming. Jet streams have contributed to climates across the world. So wherever there are cold jet streams flowing, for example in winter, you'll find that the climatic conditions change over that time. Okay, so it is all dependent on, you can say it is about jet streams, or you can say even air masses, because it's air masses which actually cause these jet streams. Now let's come to, so we already discussed two major jet streams, right? The polar front jet stream and the subtropical jet stream. So the question is whether these jet streams are there in both hemispheres. Of course they are there in both hemispheres. So why were we discussing the northern hemisphere precisely? Because as we said, it is in the continental regions that the jet streams are more expressed. In the oceanic regions, which is predominantly there in the southern hemisphere, these jet streams are not so fast and it doesn't carry a lot of air in that sense. Okay, there is another category of jet streams called low-level jets, which are typically around 3 to 4 kilometers in altitude. Now there are two of them, and both of them are near to India or in the Indian Ocean. One is the tropical easterly jet. This is very important, right? Tropical easterly jet is a weak easterly jet. Now, as I said in the beginning, jet streams predominantly move from west to east. Now, why did I say predominantly? Because there are exceptions. Now, this is that exception. This is that exception, tropical easterly jet. Now, this originates somewhere in near to the Andamans or Bay of Bengal and all that. The reason for this, and this moves a little, from westwards, that is from the east to west. This occurs around the peak of summer, June and all that. The reason that people attribute to this, development of this jet stream is the warming up of the Tibetan Plateau. The Tibetan Plateau, as we know, the average altitude is around 6,000 meters and more. And if you look at it, Higher altitudes get more incident rays, that is insolation, and gets warmed up. Now this warming is actually the cause of this jet stream. That's what people say. Now tropical easterly jet, whenever you find this weak tropical easterly jet, you can expect a decent monsoon. Or if you're not finding it, that means the monsoons would be limited, or if it would be deficit. There will be a deficit. Now coming to Somali jet. Somali jet occurs in that region where these monsoon winds, the southwest monsoon winds, actually develop. Now that means we have seen a correlation that Somali jet is actually across those regions near to Somalia, Kenya, and those regions of Sudan, Sahel and all that. So that is where this jet stream actually gets developed. This also is a seasonal one. It develops only during summer, and this contributes because the development of the Somali jet is very a prerequisite, kind of a prerequisite for the onset of, for the development of monsoon winds. Okay. Now coming to Rossby waves. Now what are Rossby waves? Rossby waves are kind of undulations, atmospheric undulations. See, Rossby waves can be there for the atmosphere. It is there in the oceans as well. Or is it there only for the Earth? No, it is there in many planets. It's there across. Now, what are Rossby waves? Now, this is found by Carl Gustav Arvid Rossby. He said that there are some waves, wave-like formations. It can be of wind, it can be of water, it can be of ions, can be of anything. And it is found in case of jet streams. It is associated with the polar front jet stream, right? And then it actually separates this sort of wave. Whenever we draw a jet stream diagram, it's always mostly in the case of a wave. Now, why is it in the form of a wave? Why? Because we have alternate oceans and continents. That's one reason. Alternate seasons, right? All these contribute to this wave-like undulations in jet streams. Now, these waves are known as Rossby waves. In meteorology, Rossby waves are associated with polar front jet stream. Subtropical jet stream not so pronounced, so Rossby waves are not really there. In case of oceans, we have, because we know something known as a thermocline layer. Okay, we'll come to in detail when we deal with oceanography. That is where you find Rossby waves in oceans. So as this diagram shows, the jet stream begins to undulate here. There's a warm tropical air and cold polar air. The air masses are actually converging here, converging in this region, and the jet stream begins to undulate. And thus this wave formation. Rossby waves are very important in understanding why. Look, there is a trough that is being formed here and here. A trough is formed here as well. Now what happens? This trough actually gets pinched off or gets separated from that main region. Now what will it cause? It will cause cyclones, extratropical cyclones. The major reason we can attribute that to Rossby waves. That's about this video. The next session will deal with humidity, precipitation and clouds. Thank you.